So here's another pretty cool example. Find the mass of a spring that's in the shape of a circular helix given by the vector valued function r of t if the density of the wire at point xyz is f of xyz equals z plus 1. So in other words, the density is 1 more than the point's distance from the xy plane. So here's our vector valued function describing our coiled spring. R of t is 1 over the square root of 2 times cosine ti plus sine tj plus tk, and t goes from 0 to 6 pi. So here's a picture of it. I needed to write this in parametric form to get a good picture, but this describes it well, I hope, for you. And t goes from 0 to 6 pi, so I think that's the right number of revolutions. And so our length of r prime of t, go back to our function here, well, the derivative of the I part, derivative of cosine, is negative sine, so 1 over the square root of 2, I said 1/2, I meant to say 1 over the square root of 2, negative 1 over the square root of 2 sine t, the derivative of this one would be negative 1 over the square root of 2 cosine t, and the derivative of this one would be just 1 over the square root of 2, the constant. So here's the 1 over the square root of 2 squared times cosine squared t plus sine squared t, because that factored out the 1 over the square root of 2, but factored out, actually I squared it and then I factored it out, and it also factored out this term. Recall that was also part of that term as well. So now this is actually pretty nice, because if you put all this together, this is 1 plus 1, which is 2, and 1/2 of 2 is 1. So wow. Our integral is just 1 plus t over the square root of 2 times 1 dt. T goes from 0 to 6 pi. Recalling this was our density function, z plus 1. So this is z plus 1, but z equals t over the square root of 2, recalling from this vector valued function, our z function is t divided by the square root of 2. So you can see that, I hope. And so that's why this mess is what it is. And this is fairly simple integration, because everything almost is a constant except for the t. So integrating 1, you get t. Integrating t over the square root of 2, you get t squared over the square root of 2. And t goes from 0 to 6 pi. When you put in 0, you just get 0 everywhere. When you put in 6 pi, you get 6 pi, and then plus, this is t squared over 2 square roots of 2, so you wind up with 36 pi squared over 2 square roots of 2, and that simplifies to 9 square roots of 2 pi squared. And numerically, that's the value you get for that. Wow.